Now we will proceed to the first keynote session. Our keynote speaker is Johan Rockström, the director of Potsdam Institute of Climate Impact Research. I think everyone knows him. He is the architect or author of the planetary boundaries, and he developed it with a great success, and now we have to know how he thinks about the current health of our planet Earth and how we can proceed in the future. Welcome, Johan, to the floor is yours.
Thank you so much, and good morning, dear colleagues, friends at the ICEF Forum 2024. What I want to do now is give a scientific update on the evidence that we now are scientifically forced to research for the first time the following question: are we at risk of destabilizing the planet? That is where we've come to. We're hitting the ceiling of hardwired biophysical processes that regulates the stability, the resilience, and the function of the entire Earth system. Global commons, large biophysical systems that we collectively depend on, are interconnected and are approaching points where feedback dynamics will go from negative, dampening and cooling, to amplifying and warming. So the ICEF focus on cooling Earth has very dramatic implications also on the risks we're facing. Now, the set of evidence for this story is quite a remarkable advancements in integrated global sustainability science and Earth system research over the past 30 years. So the planetary boundary framework is truly standing on the shoulder of giants, of the advancements of the whole global environmental change science community, with all the high-performance computing and Earth observation data and Earth system modeling. And it starts with the evidence that we are in the Anthropocene, the reference point from glaciology and paleoclimatology, that the Holocene is the only state of the planet that can truly, with evidence, support civilizations as we know it. The tipping points are hardwired. The Earth resilience is a real entity. Add these pieces of evidence together, and you land in a new conclusion. We now need to redefine sustainable development. It's about prosperity and equity within planetary boundaries. And that this is not a linear journey, it's not an incremental journey, it's about innovation and transformation at the heart of the ICEF agenda. So here we go, Anthropocene to begin with. Well, you've seen the data, it's about hockey sticks. This is the one that we tend to focus all our attention on, the temperature curve. This is something which is today making us increasingly nervous for the first time in quite some while, because we are seeing an acceleration of the warming. This is truly a concern. Over the past, from 1970 to 2014, we have a linear 0.18 degrees Celsius per decade warming. This is what has been guiding all climate models, all climate policy, the climate sensitivity that we always are focusing on, the doubling of roughly 3 degrees Celsius when we double CO2 concentrations. But then suddenly from 2014, we have a jump in the rate of warming. We don't fully understand this, but there's a risk that this has to do with the loss of health in the Earth system, loss of buffering capacity in the Earth system. We've just touched 1.45 degrees Celsius of global mean surface temperature. We are at 1.25 on the 10-year moving average, the IPCC definition of global mean surface temperature. And currently, as we sit here, Hurricane Milton is on its way as a Category 5, the strongest hurricane in 100 years to hit Florida. And of course, we are not yet ready with the science on attribution, but one thing is certain, that this rate of change, which has also the equivalent rate of warming in the ocean, means that it's exactly what we are to expect: amplified, strengthened, extreme events like hurricanes. So this is the reality we are in already today. We know the journey. It started in the 1950s with all the hockey sticks of exponential rise in pressures, loss of biodiversity, air pollutants, loading of nitrogen, phosphorus. Any parameter that matters in the Earth system for human well-being shows the same pattern. Up until 1950s, it's a linear pressure, and then we go exponential. That is the Anthropocene. That's the evidence that we've now filled up the entire Earth's surface and need to change direction and operate within the safe space. The second piece of evidence is the story of the Holocene. I call this today the story of understanding the corridor of life. And it comes, of course, from the ice core data and the remarkable precision we today have of the journey of planet Earth, actually over the past 3 million years, but here you have the past 400,000 years. Start from furthest to the right, we are today at 1.2, actually 1.25 degrees Celsius of warming. We're following a journey, as we know, to 2.7 degrees Celsius of warming by the end of this century. That's a point we haven't been in over the past 3 million years. It would knock ourselves out of the Quaternary. Now, that is so dramatic because we know that civilizations have developed in a very narrow corridor of life, the Holocene. We leave the last ice age 12,000 years ago. We enter this 14 degrees Celsius planet, plus minus 0.5 degrees Celsius. What do? We are modern humans over 2 ice ages, if you just go to the 2 first Milankovitch cycles further to the left. But we're hunters and gatherers, we're a few million people. We leave the last ice age 18,000 years ago. We enter the Holocene, this remarkable stable life corridor. And what do? We will go through the Neolithic Revolution. We domesticate animals and plants, and off we go in the civilizational journey that takes us to ICEF Tokyo in October 2024. That's the fast summary of humanity's journey on planet Earth. But it leads to one conclusion, that the only state of the planet that we know for certain can support the modern world as we know it is the Holocene. And that is what is the reference point for the planetary boundary science and why we need to redefine sustainable development. We also know that we have a broader life corridor, which goes back the 3 million years, the whole Quaternary, which is quite dramatic in itself. We've never exceeded 2 degrees Celsius, according to the latest science, the warmest temperature, and we go down to -5, and we're in a deep ice age. So you can just imagine the fact that we are on our way outside of 2 degrees Celsius is to conclude simply, there's no scientific evidence whatsoever that we can, with dignity, take responsibility for 9 billion in 2050 co-citizens in the world. So that's the reference point of the Holocene. The final point is Earth resilience and tipping points. Earth resilience is fundamental, the capacity of the planet to maintain negative feedbacks that dampen and cool the planet. Because we know that the reason the planet has stayed in the Holocene is actually not only because of solar radiation being at one stable state, it's also that the Earth system feedbacks have enabled the planet to stay in this Holocene equilibrium state. And here you have the evidence. The Global Carbon Project, as you know, releases every year the data on the global carbon cycle, the most important cycle regulating the energy instability on planet Earth. This is an x-axis from 1850 until today. You see the hockey stick of fossil fuel burning in red, deforestation in yellow, 9 gigatons of carbon per year emitted, which is roughly the 40 billion tons of carbon dioxide. Is it all of the area under this curve that has caused the climate crisis we're in today? The answer is no. As you see under the curve, you have the ocean uptake of carbon dioxide, and then you have another part with the land, intact nature, taking up together, these add up to 50% of our emissions from fossil fuel burning are not in the atmosphere. It's just the blue part that you see there that is in the atmosphere. The green parts are actually Earth resilience. It's a healthy planet responding to stress by absorbing and cooling the planet. This is a remarkable proof of the largest subsidy to the global economy, that a healthy planet applies its geophysics to help us to stay in a Holocene state. The problem is we're starting to see more and more science of this kind. There are so many papers showing that we're starting to see cracks in this ability, particularly on land. Temperate forest in Germany and Canada, boreal forest in Russia and Scandinavia, the tropical rainforest, particularly the fact that the Brazilian part of the Amazon rainforest has already tipped over, no longer carbon sink, it's a carbon source. This is a warning sign of a planet that seems to be losing health. The same in the ocean. Ocean temperatures are rising very fast, as we know. This is well predicted, it's represented in the climate models. Actually, did you know that all the climate models that hold 1.5 at the end of this century to give us the global carbon budgets, the allowable remaining amount of carbon dioxide that we can burn to still deliver the Paris Agreement, assumes that the ocean will just continue supplying this tremendous subsidy of absorbing 90% heat. 90% of the heat caused by our fossil fuel burning is not in the atmosphere, it's in the ocean. And it's just assumed that the ocean will continue to be this remarkable, stable thermostat for the planet. And then we see Hurricane Milton coming. And then we see this. Look at these curves. This is sea surface temperatures from 1970 until today. The ocean just gets warmer and warmer and warmer in a linear way. This is the assumptions in the climate models. This is what we assume as climate scientists will continue in a stable state. You see the thick line there is the 2016 El Niño, because we know that El Niño years leads to even higher temperatures naturally in the surface. But look at 2023. Suddenly the surface temperature just goes completely off the charts. It's an El Niño year, admittedly, but something is happening beyond the normal. And then in 2024, it just continues. We do not understand really what's happening. We cannot predict it scientifically. It's actually not expected. But this is another sign. So you have worrying signs on land and worrying signs in the ocean that the cooling planet may be losing its capacity to stay cool, to put it simple. That makes us approach tipping points. So this is the worry that if we push these systems too far, they lose their capacity to maintain the negative feedbacks, and if the feedback dynamics change directions, you cross a tipping point. We have been mapping these, and we are today concerned that if we cross tipping points, we may be pushing ourselves out of the Holocene. That would be the factor that can take us out of the Holocene, namely when the Earth system itself goes from dampening and cooling to amplifying and warming. Here you have the 16 climate tipping elements as we've mapped them in a recent 2022 paper in Science. There's 16 of them. 6 of them are in the Arctic, as you see here, the Greenland ice sheet being the predominant one. They're linked also to the ocean overturning of heat, the AMOC system, which is connected to the Amazon rainforest, which is connected all the way down to Antarctica. And the West Antarctica and the East Antarctica, you have the global marine systems, big biomes like the permafrost systems and the rainforest systems. These are across the entire planet. That, I think, is a key message, that these are actually global commons. These are systems that we all depend on collectively. They're spread across the entire planet, and they're in the cryosphere, they're in the biosphere, they're in the hydrosphere, and they're in the ocean. And here you have the list. Now, these 16 are actually mapped in the IPCC AR6. If you want to check, it's table 4.1, Working Group 1 report. What it does not have in that report is the quantifications of risk. Here you have the first attempt of doing that. In a IPCC methodology on red embers, the further to the right, the higher the scientific likelihood of causing irreversible changes and crossing tipping points. It's temperature on the x-axis. I just want you to look at the top 5 because the points are the average median levels. So these are the likely temperature levels, and the top 5 are likely to cross their tipping points already at 1.5 degrees Celsius of global warming. So past the Paris limit, and we're likely to push the on button of irreversible melting of the Greenland ice sheet, of the West Antarctic ice sheet, of abrupt thawing of permafrost, which is an amplifier of warming, losing all tropical coral reef systems, and collapse of the Labrador Current Sea. Just those 2 ice sheets hold 10-meter sea level rise. This is the state of science today. I would argue that this is a warning, of course, but it's also a help to humanity. That look here, we've come so far in the science showing that this is a planetary boundary. 1.5 degrees Celsius is not, as often portrayed in policy, a goal or a target. It is a limit. It's a boundary. You don't want to pass it. There is uncertainty here. Of course, science will never have the precise point when we cross the tipping point. But the likelihood of it being a threshold is so high that I would argue that we have to respect it. You may ask now, is this a group of scientists at the Potsdam Institute saying this, or is this established among the climate science community? I would say it is established today. Look at this graph. Here you have 5 IPCC assessments from 2001, the 3rd assessment, until the 6th assessment. It is the IPCC assessment using the red embers risk methodology of causing irreversible changes. And you have temperature on the x-axis. Now, 30 years ago, the IPCC concludes that the risk of crossing tipping points was in the order of 5 to 6 degrees Celsius of global mean surface temperature rise. To put it simple, there was no risk. Nobody was suggesting that we would reach just this completely unthinkable temperature on Earth. But look at the direction of travel as science advances. The more we learn of the complex, self-regulating, fragile planet, the lower is the temperature at which we now understand that we can cause irreversible damage. And it's now down to 1.5 to 2 degrees Celsius in the IPCC AR6 report. So we have support. But I want to say that scientifically, we are very likely to have underestimated the risk. And I'll just give you one example. Here's the Amazon basin, the richest ecosystem on land on planet Earth. Climate science, in the graph I just showed you earlier, we put the risk at 3 to 5 degrees Celsius of crossing a tipping point. Ecologists like Professor Carlos Nobres, Professor Mercedes Bustamante, the leading Brazilian scientist, tells us we're wrong. Because if we lose more than 25% of the forest canopy, losing biodiversity, opening up the tree system so we lose the moisture recycling capacity of the rainforest, itself generates 40% of its own rainfall in a healthy state, we are then likely to cross the tipping point, irreversibly losing the entire basin, already at 1.5 to 2 degrees Celsius, if we go beyond that 25% loss of canopy. Where are we today? At 17% deforestation and 1.25 degrees Celsius warning. So it's not surprising that Professor Carlos Nobres, the world's leading climate ecologist on the Amazon in the world, says in public, we are very close to a tipping point in the Amazon. That's not what we climate scientists dare to say yet, but if you take the interactions between these two boundaries, biodiversity and climate, we're probably very close. The path to a landing, therefore, is very steep. And we need to have an integrated approach. This is why we need the planetary boundary framework, because we have identified the 9 Earth system processes that scientifically are proven to regulate the stability, the resilience, and the life support on planet Earth. You have those 9 here. It's not only climate, it's also what I call the biosphere boundaries, biodiversity, the hydrological cycle, the bloodstream of the whole planet, the nitrogen-phosphorus cycle, the nutrient cycles, and the configuration of land biomes. But it's also pollutants, aerosol loading. It's also chemicals, novel entities. It's also the stratospheric ozone layer, and of course, ocean stability. 6 of the 9 boundaries are outside of the safe operating space. That's what you see here. We've been able to quantify the safe space, and this is the 2023 update. This is a proof of a planet that is starting to lose resilience. We have, for the first time, been able to add this up into an annual update. So 2 weeks ago, we presented in New York Climate Week the first so-called planetary health check, where we updated all the boundaries, confirming that 6 of the 9 are outside of the safe space, and even putting them on a kind of plot chart, which you can think of as a health check, as a blood sample check. And when we place the planet based on all the 9 boundaries, we conclude that we are outside of the safe space for the planet. We are in this uncertainty range in science, the yellow range. We're not yet in the high risk zone, the red zone. So we're just at the edge with a planet that is trying to do its best to cope with the stress, but is starting to show sign of losing resilience. This is a warning, but also gives some light in the tunnel that we can still veer around and have, according to the science, a chance of a safe landing. Here you have the latest update with the 9 boundaries, according to this blood sample test type of diagnostic. 6 of the 9 boundaries are confirmed to be outside of their safe space. What is new here is the arrows. And this is, of course, really worrying because all the 6 boundaries are still moving in the wrong direction. So we've not turned the corner, we've not bent the curves on any one of these. That is, of course, showing the urgency of what we need to do now. It's a transformation pathway. It's therefore not about linear change anymore. We have to have innovations and social system transformations to come back in for a safe landing within a prosperous and equitable future for humanity. If we do not turn this around within the next 5, 10 years, we don't have to solve the problems in the next 5, 10 years, but we have to decisively bend the curves. Otherwise, we'll continue drifting towards a state that will have more and more risk of causing irreversible damage for humanity. Now, the path for our future is therefore to truly become stewards of the planet. I think that is scientifically well established today, and it's also quite well established that it's a steep journey. It's no longer a linear journey of incrementality, it's a journey of transformation and innovation. That's why the ICEF gathering is so important, to be able to have that discussion. How do we truly move towards system change in the world? Thank you so much.